Welcome. This is a lecture on a graphical presentation of data. We're gonna talk about some types of graphical presentation. There's a lot more than what is in this lecture, but we will select some that are more important than others for us. The first type of graphical presentation is a type of a line graph that we call actually time series plot. The essential for this plot is that we would have on the x-axis time units. Now in this particular case I'm presenting the attendance of my students in a calculus class throughout 10 days, probably first 10 class sessions. So these are not necessarily consecutive dates, they are actually consecutive class sessions. So on the first day I have 28 students. On the second day, 23 students. On the third day, 24 students, and on you go. On the 10th day, I have 21 students. You could use this as an X and Y for the points. The first day, 28. The second day, 23. So 2 and 23 is a point. The third day, 24. The point is 324. So you point plot each day, and then you connect the points by using line segments. So we have this type of a line graph. The actual name is a time series plot. This will give you an idea about the trend. I can see the trend is dropping from the first day to the 10th day, not uniformly. There are some larger drops, some another one larger drop here, some recovery here and on, but in general is trend is dropping, which is not a surprise in terms of attendance in the first class session to me. This could look a lot more elaborate. This is a very simple one. The next one is a vertical bar graph. We have vertical and horizontal bar graphs. So this is the vertical bar graph that tells you something about the age distribution of 2016 election. The bars are proportional. That represents the percentage of voters in the age group. So for example, the age group 30 to 39, we have about 51% voting for Hillary Clinton 2016 election, and about 40% voting for Donald Trump. So they're color coded relative to the candidates. So you can see some trend as the age increases. The candidate Trump has more percentages of voters, and as the age decreases, the candidate Clinton had more percentage of the voters. So this is an interesting age distribution. Here's another graph of the recent election, 2020 presidential election between Joe Biden and Donald Trump. You can see what we call key demographics, which would be gender, race, and age. And you can see that also again the distribution in the gender. We have the male voters are 51% voting for Donald Trump, 45% for Joe Biden. In the female gender group, we have 57% voting for Biden, 37% voting for Trump. Gives you some idea about discrepancy in terms of a gender, and so on. You have that in racial distribution and age distribution. This is a type of a horizontal bar graph. We will also talk about histogram. That's a separate lecture. The next type of a bar graph is a Pareto bar graph. Now this is a kind of a graph that it's a bar graph, but data is also organized in some sorting fashion, either decreasing or increasing order, ascending or descending. So in this particular case, I'm presenting the GDP, power purchasing parity per capita of top 10 countries, estimate by International Monetary Fund for 2020. So the GDP, of course, is the gross domestic product per capita, but also divided with respect to what you can buy in a particular country. So power purchasing parity. We have a lot of money, and the the things you want to buy are very expensive, then you really don't have that much money. So this is a relative to the power purchasing power in the country. Nevertheless, you see the Qatar, the Gulf country, doing the best, way the best here. Macau, city-state on the coast of China, or I should say it's part of China. Then we have Luxembourg, European country, Singapore, city-state on the Malaysian Peninsula, Ireland, European country, Brunei, a small state in Indonesia archipelago, Norway, which is a European country, two Gulf Coast country, United Arab Emirates and Kuwait, Switzerland, European country, United States, here we are, number 9, and Hong Kong city-state, part of China. So these are the GDP per capita. If you make a Pareto graph, you would put it in a sorting order. It would probably be in descending order, like this. The labels are usually very easy to recognize in Pareto graph. They're usually written on the bottom, and they of course represent what the classes are about. The bar size, the height of the bar, is proportional to the value of the GDP per PPP per capita, and then you can see, you can have a better idea from this visual presentation than just from raw numbers. You see the last four about all the same. There is a slight jump here and a fifth from the bottom. The top one is significantly higher than anybody else, so that gives you some idea about the numbers you're trying to present. GDP, in this particular case, gross domestic product per capita. Okay, another type of presentation we use very often is a pie, circle chart and graphs. Very often used in business and in magazines, media like this type of presentation. Here I'm presenting the grades of 20 of students of mine in a calculus test. The first student scored 77%, the second 32%, the third 56%, and on you go. I have that divided into grades. I have 4 A's, 4 90s, 1, 2, 3, 4, and of course you can count B's, that are 80s, 2 C's are 6, D's 1, and people below 67. Not all the same. 55, 56 is almost 57, or 55. It's almost passing, but there are some another 55. There are some that are not doing so good. So this 32 and another 32%. Okay, now the data is presented in a fashion of pie slice, or a pizza slice if you like. So you need to make a circle. You need to find, oh, this is a really bad circle of mine, sorry. But here is much better, of course. And then you have something we call a circular sector. This is a circular sector. Okay, you have to do that by measuring. And the circular sector ought to be proportional in terms of area. So this sector, color-coded here, represents grade F. It should be 7, the biggest sector. We have grade D and C combined 7. So this and this should be exactly the same in terms of area as this. Then you have A and B, which is 6. So B should be half of A. You should measure this. And then, of course, when you combine both A and B, it should be the same as C, because their A and B combined is 6. The C is 6, so this area here and this area ought to be the same. You should actually use degrees to measure this properly. So you divide 360, 6 out of 20 students, 30%. So that ought to be 72 degrees for C, right? And you measure the rest of them too. You don't have to measure everything. For example, once you have a C, you know that A and B are going to be the same. That B must be the half of DA, the D must be the half of C, and of course I said already F should be combined, both C and D. 7 is in C and D and in F. Okay, in either case ought to be proportional. The area ought to give you presentation of the data. If you don't do that, then your graph is not really worth as a graphical presentation. If this is hard to read for people that can't read colors, colorblind, then you might want to write here. So you would write here A. And if the proportion is not entirely visible, you might want to do something like this. So we have A, and we put like that outside. We have here, I have to be careful about colors. This would be C, and then C is 6, and on you go. You can do a little more. Some people like to have that in 3D, which is another thing to add to graphical presentation. I didn't do that here. Stem and leaf display. That is also graphical display, but it's more than that. It serves also for sorting. So I have a sample of 40 here that is representative of the carry-on luggage weight in pounds from Hawaiian Airport. Okay, so if I want to organize this data, I want to sort it first. I might do that by using computer, but if you don't have that readily available, you're gonna do something like this. You're gonna have sorted that into single digits, into tens, into 20s, into 30s, into 40s, and into 50s. Okay, on the top you probably want to do some kind of guide for the people reading your data. So you can select any piece of data like 21, and you put 2, which is going to be our stem, and a leaf, which is going to be 1, and then you write further on what that's supposed to be, like I did here, 43, as in 43, meaning 43 pounds of carry-on, maybe even luggage here if you want more. And then you start sorting. 3, so this is going to be for single digits, this is going to be for teens, for 20s, then it's going to be for 30s, I'm squeezing that, it's going to be for 40s and 50s. And if you're going to sort that, you have to be very careful. So this is my 3. I want to pronounce this a little more. And you start 30, 30, 27, 27, ought to be a line. 12, 1, 2. 42, 2. 4, 2, right? 35, now next alignment is gonna be a determine. So the 5 would go here, and every second item in other classes would go in the same alignment. Okay, this is done really poorly. I had to use the ruler, obviously, but here is one much nicer. This is still not sorted. It's not the end product. It is not a stem and leaf display yet, because the data is not sorted. But you already have divided data in the classes. You already have a graphical presentation. Now the sort. The data in the first class in single digits is 3 and 0, so you want to reverse the order here if you want to sort that. In the second one, we have two twos. We don't have a 3, 4, 5, or 6, but we have a 7. We have a 3 8s and 1 9. So sort that. It's much easier to do that once you have smaller classes and you have to sort only single digits. The same thing in the third class. I guess I have 3 1s that goes forward, and on you go. Once you sort all of that, you have stem and leaf display. This is a stem and leaf display. It gives you a couple of things. It gives you the sort. You can just count 0, 3, 12, 12, 17, 18, 18, 18, 19, and so on. The last one is 51. It also gives you almost like horizontal bars. So this would be like the biggest bar here, then there will be a shorter bar here if I do the horizontal bar. And that could give you an idea about the comparison between luggage that is in 30s, luggage that is in 20s, almost double then, or probably double, more than double than what is in 40s, and so on. So it gives you graphical presentation. That's why it's important as a graphical presentation. It also gives you us mechanism, the method to sort the data. Nowadays we use computers, so sorting is done with the computer. Also, bar graphs and time series plots could come up in all sorts of hybridized format, sometimes in the format that is going to involve different types of graphs or the graphical elements, not necessarily a single type. So here is an example. We are presenting a graphical presentation of the data of deaths in the United States from COVID-19 from July of 2020 till the mid-February 2021. So you can see lots of different elements. Of course, we have a timeline here, the x-axis. So that's some type of a time series plot. There is a curve here, which is actually a polygon. It's made from line segments, but they're very small, so it's looking like a curve. Those are the average 7-day averages, and then we have each day that's presented by a vertical bar. So we have here on January 15, 3,709 deaths. There are some other elements here. So this is a combination of a line graph and a vertical bar graph. It's a time plot as well. You can also see some other elements here. There are 4 bars here that pronounce as some bars that were with some backlog data. So they don't represent particular day, but something that is reported on that day that was not reported before. That is another type of an element that we didn't talk about. So this is a hybrid graph, a graph that involves multiple elements of different types to represent the data. Again, it's not very difficult to read. As a matter of fact, you need to spend some time, obviously, to pick up all of the elements. What do they mean? That, of course, this graph, like many graphs, would have some kind of description, a title, and some other description that should be obvious to people that are going to be analyzing this kind of the data. So again, I said we are separating one graph, one type of a diagram, one type of a plot that we call a histogram as a separate lecture. I want you to study that, and we are going to do that in a different lecture. This lecture is also posted on the Blackboard, so you can read what I was reading myself here while I was doing this video for you. I will end the stream. I hope you can do the homework on time. See you on the next lecture.